All right, this is a video that finishes up a couple of the problems that were left over in section 2.3 of our brief Cal notes. So we're looking at the marginal rates of economics. And we're going to be looking at some definitions of things and how do we know what to do with these and how is this related to derivatives essentially. So another important use of rate of change, which remember is slope, is in the field of economics. Economists refer to marginal profits, marginal revenue, and marginal cost as the rate of change of the profit, revenue, and cost with respect to X. Remember, X is the number of units produced or sold. So we have our P function, which is our total profit. We'll have an R function, which is total revenue. C is always total cost. And remember that we have a relationship that profit is revenue minus cost. The derivatives of these quantities are called the marginals. If you take derivative of profit with respect to X, you get marginal profit. If you take the derivative of the revenue function with respect to X, you get the marginal revenue. And if you take the derivative of the cost function with respect to X, you get a marginal cost. So here is a problem where they've already given us the profit formula, so we don't have to find it ourselves. It says the profit in dollars derived from selling X units of an alarm clock is given by P equals 0.0002 x to the third plus 10x. Find the marginal profit for the production level of 50 units. So because of the word marginal profit, we know we need to take the derivative of P. So dP with respect to X is, and that would be of our P function. If we take the derivative of this, this would be dP of dx of 0.0002 x to the third plus 10x. That's our function. And then we do our power rule here. So we bring the power to the front. And remember, we reduce by 1 power. So we bring 3 to the front and multiply that by 0.0002, and we get 0.0006. And then we lose a power when we take the derivative. So that's now x squared. Plus, this is 10 x to the first power. So we pull the 1 to the front, so that'll still be a 10. So 10 times 1 is 10. And if you reduce a power, you get x to the 0, which is just 1. So this is our derivative right here. Now, they gave us a specific value for X to plug in. We're going to be plugging in 50 units to know what is the marginal profit for that amount of units. So 0.0006 times 50 squared plus 10, and I've already worked this out. I got $11.50 per unit. Now that's called their marginal profit, okay? We want to compare the marginal profit with the actual gain in profit obtained by increasing the production level from 50 to 51. So if we have 50 units and we want to increase that to 51, we want to see, is that close to the 1150 that the marginal profit estimates? So when we do this, you're actually going back. Actual gain has to do with the original function. Marginal profit, remember, has to do with the derivative. So we're going to be doing P of 50 and P of 51 in the original function to see how much we actually gained. So if we do P of 50, that's 0.0002 times 50 cubed, because remember, we're going back to the original function here, plus 10 times 50. And I got that came out to 525. I was looking at the wrong line. So $525. If we plug in 51, I got that it came out to 536.53. The actual profit, not the marginal profit, is that you take the large one and you subtract, or the newer one, we should say, because it won't always be a gain. Sometimes you'll have a loss. But you take the newer value, which is the one where you sold more units, and you subtract the one where you sold less units. And that came out to $11.53 per unit. So pretty close to that marginal profit. Okay, let's do one more. This one is the cost of C in dollars producing X units of a product is given by C equals 3.6 times the square root of X plus 500. Find the marginal cost when X equals 9. So because they've said marginal cost, we know we need to take the derivative of C. So dC with respect to X of 3.6, since that's a square root of X, I'm going to go ahead and write that as X to the 1/2 power plus 500. Okay, if we take the derivative of that, we take 1/2 and take it to the front and multiply it by the 3.6, which is going to be 1.8. We subtract 1 from the power, so that'd be X to the negative 1/2. And then the derivative of 500, since there's no X, that's just going to be 0. So this ends up being 1.8, and we're going to move this to the bottom because it has a negative exponent and turn it back into a square root of X to the first. So that's going to be our derivative function. If we want to plug in the actual X equals 9, that would be 1.8 divided by 3, which comes out to approximately 60 cents per unit. So that's their marginal cost. If we want to find the actual additional cost when the production is increased from 9 to 10 units, we do the same thing we did before. Since we're doing actual, we're going to use the actual C function. So C of X equals 3.6, and I'm going to plug in 9 first. Square root of 9 plus 500. I got that came out to 510.80. And then, so this was for 9. If we do C of 10, that's 3.6 times the square root of 10 plus 500. And using my calculator, I got that was approximately 511.38. To get the actual cost, we subtract, remember, the one that had more units from the one that had less, so we know if that's actually an increase or a decrease. And it looks like this comes out to about 58 cents per unit. So notice this marginal information is pretty close and dead on to what we see in the actual. And that's the end of the 2.3s that we had left.